All right, Algebra 1A students. Welcome to part 1 of Lesson 2.2. In this video, we'll be solving two-step equations, isolating a variable, getting it all by itself in the same way that we were doing in our last videos. But these equations are going to involve two steps in order to isolate that variable by itself. But the process we're going to go through is basically the same thing as we did in our last video with one-step equations. We're still going to be undoing certain operations with their inverse operations. Just a reminder that inverse operation means the opposite, so multiplication and division are inverses, and then addition and subtraction are inverses. So to solve two-step equations, or to isolate a variable in a two-step equation, we just have to undo two different operations using the inverse. The important thing to remember in these problems is that we have to undo the operations in exactly the opposite order of the order of operations. So hopefully we remember the order of operations, which is PEMDAS, or GEM, a lot of different ways to write that, but PEMDAS, remember, said to do parentheses, then exponents, then multiplying and dividing, and then adding and subtracting. So when we are undoing operations using the inverse, we actually do things in the opposite order. So we start with undoing addition and subtraction, and then we undo multiplication and division, and then we would undo exponents, and then we would last undo parentheses if we have them. Most of the time, though, we'll just be dealing with addition and subtraction, multiplication and division. So make sure that we undo addition and subtraction first, then undo multiplication and division. Let's look at a quick example here where they give us the equation 2 times x plus 3 equals 15. The first thing that we need to do to solve this equation, or find the solution to this equation, the value for x that makes this true, is to identify what is happening to the x variable in this equation. So the first thing I notice is that right here it is being multiplied by a 2, and then here it's being added by 3. So I have two things that are happening there. It's being multiplied by 2 and it's being added by 3. So I need to undo both of those operations, undo the addition with subtraction, and undo the multiplication with division. And as I just mentioned above, we're going to undo the subtraction first. So the first thing that I'm going to do is I'm going to minus 3 from both sides of this equation. Minus 3 and minus 3, which will leave me on the left side of my equal sign with just a 2x. And on the right side of my equal sign, I'll have 15 minus 3 on that side as well will equal 12. So my equation now says 2x equals 12 after I undo that addition that was happening to my x variable. And now I can undo my multiplication because that's all that I'm left with on the left side attached to my x. So I'll undo the multiplication by dividing by 2, divide the other side by 2 as well to follow our division property. And we end up with x equals 6 in this case, because 12 divided by 2 is 6. So we undid the addition by subtracting 3. We undid the multiplication by dividing by 2, and we end up with our answer, our variable all isolated by itself, x equals 6. Okay. Another quick example that looks slightly different. Here they're asking us for the solution to the equation 5 equals t over 2, or t divided by 2, minus 3. So once again, the first step in our process is to identify what's happening to our variable here. And I see two things again. The first thing I notice is that it's t over 2, which means t divided by 2. So my variable is being divided by 2 and it's being subtracted by 3. So I have to undo both of those operations, the subtracting by 3 and the dividing by 2. I'll undo the subtraction by addition, and then I'll undo the division by multiplication. And I'm going to undo the subtraction first because I'm going backwards again in my order of operations. So the first thing I'll do is I'll add 3 to both sides of this equal sign. So add 3 to get rid of the minus 3, and then add 3 on the other side to the 5. So now my equation, once I add 3 on both sides, has an 8 on the left side because 5 plus 3 is 8. and that is equal to, the only thing left on the other side is t divided by 2. So I have t, and then a fraction bar, and then a 2 underneath. So my equation now says 8 equals t over 2, and now this is a one-step equation that looks just like what we were solving in our last video. We have one step. We have one thing that's happening to the variable now because we've already undone or done the inverse of this minus 3. So I now need to undo the division by 2 here. T divided by 2 gets undone by multiplying both sides by 2 because the inverse of division is multiplication. That'll cancel the 2, and I'll be left with t on that side. But I have to remember to do the same thing to the other side of my equal sign as well. So the left side of my equal sign now says 2 times 8, which we know is 16. And then the other side just equals t, because that's all that's left. We've undone everything that was happening to the t. So we end up with the solution, t equals 16, or 16 equals t. So this process looks very similar to what we were doing in lesson 2.1, but we're now adding another step. We're adding another operation that we have to undo. And now the order is important for us, that we do it in the opposite order from the order of operations. So using these two examples to guide you, I'd like you to try these two problems here. I'd like you to try solving these for x and for m. So pause the video and take a couple minutes to do this on your own. Then come on back and I'll show you what we should have. In number 1, after we subtract 12 on both sides, we should end up with 5x equals negative 25. And then, obviously, the next thing to undo is the multiplication. We divide both sides by 5, and x is equal to negative 5. So in number 1, we should end up with x equals negative 5. And then over here, number 2, we should end up with m equals 63. Because we add 3 to both sides, and get that m divided by 7 is 9. And then we undo the division by multiplying by 7, and 9 times 7 gives us 63. So if you have questions at all about what order to undo these operations in, or how to undo any of these operations, again, addition, subtraction, multiplication, division, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.